Hi everybody, in my previous video on this playlist I introduced the basic concept of regression and I gave you the equations for how we're going to come up with everything needed for the regression line equation. Now in this video I'm going to actually walk you through with an example and show you how to obtain the values in order to make a prediction of the value of one variable if we have the value of the other variable. So let's see how that works. All right, quick recap of what we've covered so far then. When we have a correlation coefficient, we can use that information and some other information in the data set to then come up with what is called a regression equation. The regression equation tells us exactly where a line is going to be that best represents the value of one variable, the relationship between these two variables. And not only does it just represent the relationship, because a correlation does that, but the line itself represents our best guess for what the actual relationship of these two variables is. Okay, so let's now apply this all and use an actual scenario. Of course, once again, I've made up the data just for purposes of practice here, so bear with me. Let's imagine there's somebody named Walter. Walter runs this doggy daycare, and he's interested in just how much he spends based on how many dogs are there. So he's very curious about his budget, and he wants to have better planning ideas here for just how much he needs to plan on spending based on how many dogs are there. So he's thinking specifically of this upcoming Thursday that he has, okay? He has 11 dogs coming on Thursday. They're scheduled to be there and he watches them all day on Thursday, okay? And of course, there's a lot here that we're not exactly clarifying. It doesn't matter. Just imagine that we've kind of done our due diligence here in defining everything and all that. We're going to work mostly on the statistics here. Okay, let's imagine he's kept very good records over the last 3 months. So he's every day he writes down how many dogs were there, and let's say every day he also writes down just how much his expenditures were on supplies, things like dog food, his trash and stuff like that. Just everything it takes to take care of that many dogs in his own expenditures. Okay, we're going to call that the cost of supplies or his expenses. So with these records, he was able to define that he has an average of 13.05 dogs every day on in his daycare, and he spends about $150.90 of supplies. So this is all the averages. Again, he's calculated that for us. I've had previous videos that show you how to calculate those things, of course, the means, if we have the data. Just for the purposes of this video, however, he's done those calculations. Similarly with the standard deviations, he's already calculated those for us. Again, I've shown you how to calculate those in previous videos, so go look at those if you're not sure how to do that. But let's imagine he has a standard deviation of 2.8 dogs and $29.42 of expenditures. Okay, so what we're going to do here is we're going to call the number of dogs present the X variable, and we're going to call the amount of expenditure the Y variable. What we're essentially doing here is Walter's saying, I want to guess what my expenditures are going to be as precisely as I can if I know I'm going to have 11 dogs on Thursday. So he's saying, what is my best possible guess in expenditures for these dogs on Thursday? So essentially what he's doing is he's giving us that X value in our regression equation, right? You recall that this is our predicted value of Y, or the predicted value of our expenditures, because as I said, our expenditures are the Y variable. This is the intercept of the line, this is the slope of the line, and he's saying, but I already know that my X value, the value of my X variable, is 11 because I expect 11 dogs this coming Thursday. Okay. Now we know that as he told us, no, he didn't tell us this yet, I'm sorry, but he's telling us now that they are correlated at 0.31. The X and the Y variables are correlated at 0.31. Now again, if you don't know how to do a correlation, I have a previous video on that as well. And let's say that he's already calculated all of this for us. But if you've been watching these videos in sequence, what he could do is just give us his raw data, and we could do all of these calculations for him. It would just take a little bit of time, right? Okay. And he knows the means and standard deviations of both variables, as I covered in the previous slide. So now what we're going to do is predict the value of Y based on his value of X that we know. Okay, as I said in the previous video, we do need to calculate B before we calculate A. B, again, is the slope of the line. So we need to figure out just how much slope there is. This is the equation to do that. Again, we have the R coefficient, or how much the X and Y variables are correlated with one another. Then up here in the numerator is the standard deviation of the Y variable. Down here is the standard deviation of the X variable. So using those values that Walter gave us, he said that they were correlated at 0.31, a positive correlation. There was a standard deviation of $29.42 spent per day, and a standard deviation of 2.8 dogs present at the daycare. Okay, now the math is pretty straightforward here. We can multiply 0.31 by 29.42, or if you prefer, you can divide 29.42 by 2.8, then multiply. It doesn't really matter. I've multiplied here first so that I get a numerator of 9.12. I divide that by 2.8, and I get a value of 3.26. What that means is, for every additional dog that comes to his daycare, assuming a linear relationship, I should also add, he spends $3.26 more. So for each additional dog, he spends on average $3.26 more for that dog. Now this is important. We now have the slope of the line. In other words, we know how much it rises for every time it goes over 1. Let me show you this in a scatter plot. So let's take stock of what we know so far. If we have the slope, we know the general incline of the line. In fact, we know the precise incline of the line estimated based on the data that we have. And it looks like this in our particular case. In other words, what we're saying is, for every time I add a single dog to my population, I appear to increase my expenditures by $3.26. So going from 13 to 14 increases the estimate of my Y value by $3.26. And then when I do the same thing over here, I add 16 to 15, or I add one more to 15 to get 16, I get that increased expenditure over here. However, you'll see I've got multiple lines here. That's just to illustrate that so far all I know is that this is the incline of the line. But without my intercept, I don't know where it's supposed to intersect or cross over that Y-axis. And so that's why I need to establish what the value of A is. So we'll do that now. Okay, so we now need to calculate A, which is the value of that intercept. In other words, it's the value of the Y variable if our X value equals 0. In other words, if we expect X to equal 0, it's where that what we expect that Y value to be. This again is the equation. We've got A equals the mean of the Y variable minus the mean of the X variable multiplied by the slope that we just computed. So if we use Walter's data, here's what we end up with. He had a mean expenditure per day of $150.90. We knew the slope now, right? We just calculated the slope. It's $3.26 per every increase, 1 unit increase in dogs. And this is the value, or the mean of our X variable. He has an average of 13.05 dogs per day at the unit. Now that's very easy to solve this then. We just take 3.26 times 13.05 to get 42.54. Now I've rounded ever so slightly, but that's fine. We're close enough. Then the difference between 150.9 and 42.54 is of course 108.36. So in other words, what I'm saying here is that I now know where that line is going to intersect with the y-axis. I know where it crosses the y-axis. If x is equal to 0, I expect to spend $108.36. Let's take a look at that on a scatter plot. So now knowing where the intercept is, I know that the line's going to cross right here at about 108. At least that is my absolute best estimate given the data that I have. I have no reason to believe that it over or underestimated, right? And so I go with that as my default beginning, my guess. Now, what I've shown here is that if I don't have the slope of the line, right, then I don't know what the gradual increase or decrease is. And so if I just have the intercept, I know it crosses here, but I don't know where the rest of the line goes. That's why it's, of course, vital that we have both the intercept and the slope of the line. Okay, so now let's put this all together and start to estimate what Walter should expect for Thursday. Okay, so to put together everything that we know about Walter's data so far, we've obtained this regression equation. This is the regression equation we have for Walter's data. Okay, what we're saying here is that to predict the value of the y variable, given a value of the x variable that we'll input, whatever it is we want to input, this is our best guess at how to decide what that predicted value would be. We start at 108.36, that y-intercept, and then we multiply our x value by this slope, then add whatever that value is, that product is, to this intercept, and that's where we will find our predicted y value. Okay, so this tells us exactly where our regression line goes on a scatter plot. So actually, let's take a look at it on a scatter plot to see just how much it slopes and where it crosses the y-axis. So this is essentially putting together both of those scatter plots I showed you already. Now that I know not only the intercept, but also the slope, this is what the value will look like. Now, here's a quick tip on how to figure out that exact line. If you're not sure, like if you're not sure how to read it, you can just put in any two random values essentially to that equation as the x value. And as long as you have two, you can then pinpoint these two things and then draw a straight line between them. And that's all you have to do. You could put in 0 as the x value and then calculate it out to find out what the predicted value would be. Obviously, in this case, it was 108.36 or whatever. And then you could put in another value. In this case, you put in 13 or something. 12, 14, 15. 15 is what we put in here. And it'll give you the value of y. And so now you just draw a straight line between those. That's all I really did to make this equation. But this is exactly the regression line for this data set. Okay, so now let's figure out what is Walter's best guess for his Thursday expenditures. All we do there is because he has 11 dogs scheduled for Thursday, we just put in that known value of x, then we're figuring out our predicted value for y. Of course, 11 times 3.26 is 35.86. 35.86 plus 108.36 is 144.22. In other words, if Walter has 11 dogs on Thursday, our best guess for his expenditures, based on all of his other data of the last 3 months, is that he'll spend $144.22 on those supplies. Okay. So bringing it back to our scatter plot, again, I've left all of the data points off of this just so we can see the regression line clearly. What we've got here then is the representation of the relationship between the two variables. And what we've just done here is we've said if we know the value of the number of dogs that are going to be there, or the x variable, then our best guess is to look right here for the value of the y variable, or how much money he's likely to spend on supplies. And so our regression line tells us if we know the value of the x variable right here, then we can also see where it's going to line up over here on the y variable. We just take a horizontal line directly across to see where it intersects there. And as you can see, it's at about 144 point whatever it was. Okay, so that's it for regression. Again, a very basic idea here that I've just introduced. It's essentially just taking correlation, adding a little more information to find the regression equation so that you can predict one value based on a known value of the other one. So that's it for that. I'll see you in the next video. Thanks.